Now what I want you to do is grade this thing. Use a red pen. And this is what I want you to do. Well, number one, it says in the problem, if you look at the problem carefully, it says two identical spheres are released at t equals 0 from the same height as shown above. Sphere A has no initial velocity and falls straight down. Sphere B is given an initial horizontal velocity of v0 and travels horizontally a distance d before it reaches the ground. The spheres reach the ground at the same time, t final, even though sphere B has more distance to cover before landing. Air resistance is negligible. A, the dots below represent sphere A and B. Draw a free body diagram showing and labeling the forces, not components, exerted on each sphere at time t final divided by 2, so half the time. Okay, so here are your dots that were given. Now, even though sphere B has a horizontal velocity, and now we're, I don't know, we're down here somewhere, or halfway, we're up here somewhere. What's the only force acting on sphere B? Gravity. It's a projectile. It's halfway down. Yeah, somebody had to give it a push to give it that horizontal velocity, but nobody's giving it horizontal velocity anymore. It's got all the horizontal velocity it's going to get because the only force acting is gravity, and that's straight down. So it's going to change its vertical velocity, but not its horizontal velocity. Does that make sense? So if you missed this, fix it in red pen, and I want you to write an explanation on why that's the correct answer. Okay? So it's kind of like when we do a homework quiz. Tell me what you did wrong, fix it, what did you learn from it? Because you might get a problem like very similar to this on the actual AP test. Then, if you then it says part B. It says on the axis below, sketch and label a graph of the horizontal component of the velocity of sphere A and of sphere B as a function of time. Now, here's the key thing. You have to read the test carefully. What does it say? On the axis below, sketch and label a graph of the horizontal component of the velocity. So not the vertical, the horizontal component. And what's the key idea? What's true about the horizontal velocity of projectiles? They're constant with time. So if you look at this, sphere A has 0 horizontal velocity the whole time. Does that make sense to you? Now, if you got it wrong, you need to do this in red pen and explain what you did wrong, fix it, what did you learn from it. And then up here, B, you can arbitrarily, it doesn't matter what line you choose, but its velocity is going to be V0, and it's going to be a constant horizontal line, but it's got some velocity. Yes, question?
So after a certain amount of time, we drew that the velocity V goes directly to 0 because after it hits the ground, it stops.
Okay, it will, but really, we're only looking at, like, if you took both of them, or like B, and then like right at the end make a downward plunge, that might not be wrong. But really, we're only looking at the projectiles while they're in the air. Like after they've left that little table and before they actually hit the ground. Just before they hit the ground. Yeah, when you're dealing with projectile motion, you don't almost never deal with what happens after it hits the ground because it's just too complicated. Now here's the hard part. You have to read your paragraph, and this is what I want you to do. I want you to read the first sentence. For indicating the difference in the horizontal motion does not affect the vertical motion of the spheres. Did you write that anywhere? If you did, underline it and give yourself a point. If you didn't, write that down, that you should have included that in red pen. Did you indicate that both spheres start with the same vertical velocity? Or you can say that their initial velocity in the y direction was 0 or whatever. They have the same vertical velocity. If you did, underline it and give yourself a point. If you didn't, you need to write that down, that you should have put that in your paragraph. For indicating that both spheres have the same vertical acceleration. Okay? Or you said they're both under the influence of gravity. They both have the same acceleration. It's 9.8 meters per second squared down for both of them. If you said that somewhere, give yourself a point. For indicating that that falling the same height would take the same time, give yourself a point. And then for no incorrect or irrelevant statements. Now this one, you really have to write something that's wrong to lose a point here. And this takes judgment to grade this. I am so glad I am not an AP Physics grader, because they have to read these paragraphs and try to find these points in your paragraph. Okay? So do that now. Give you about 3 or 4 or 5 minutes to grade your and correct this. It should be in red pen, and then we're done with this assignment. Any questions on what you're supposed to do? Okay, that is all.